Question 1 said find the sum of the first 30 terms in this arithmetic series. So -5 is the first term, so that's A. Then you need to get your common difference. Okay, so term 2, take away term 1. So that's 2, take away a -5, which becomes 2 plus 5, which is 7. So there's a difference of 7 to go from a -5 up to a 2. 9, take away 2, 7. So I've just confirmed it. Get your S of n formula then, and I want to get the sum of the first 30 terms. So S of n for an arithmetic sequence, which comes from page 22 of the log tables. N is 30. Sub it in. A was -5, and your common difference was 7. You can put it all into the calculator in one go if you want, or you can tidy up inside that curly bracket and then multiply it by 30 divided by 2 is 15 afterwards, and you'll get 2,895. So that was question 1, part 3. Question 2. The sum of the first 80 terms of that particular series is, S of 80 equals the sum of those terms, right? That is the sum of the first 80 natural numbers. Natural numbers are positive whole numbers. Find S of 80. So again, it's an arithmetic sequence because there's a common difference of 1 between each term. So put down your S of n formula. A is 1, common difference is 1, and n is 80. Subbing into that, you'll get 3,240 for the sum of the first 80 natural numbers. Question 3. Find the sum of the first 30 odd natural numbers. Okay, so again, the sum of the first 30. A is your first term, which is 1. The common difference is 2 every time. Put down your S of n formula. Sum of the first 30, so n is 30. A is 1. Common difference was 2. You'll get out 900. So the sum of the first 30 odd natural numbers, is 900. Question 5. Given the arithmetic series 2 plus 10 plus 18 plus ... find the sum of the first 20 terms. Okay, so you put down your S of n formula for an arithmetic series. A is 2, and the common difference each time is 8. They're going up by 8. So I put down my S of n formula. So S of n equals n over 2 by 2a plus n minus 1 times d. And I get out 1,560. So the sum of the first 20 terms of that sequence would be 560, sorry. Find the sum of the first 40 terms. So now I'm getting S of 40. So it's going to be 40 over 2 by 2 times A, which is 2, plus n minus 1 times d. And you get 6,320. So the sum of the first 20 terms was 1,560. The sum of the first 40 terms was 6,320. It then says hence. So using what you just did, find the sum of the second 20 terms. So the sum of the first 40 terms, take away the sum of the first 20 terms, would leave me with the sum of the second 20 terms. So it's just subtraction of those two answers. So the sum of the second 20 terms is 4,760. Question 6. On the 1st of January 2015, John opened a bank account and he deposited €100 in the account. So that's on the 1st of January 2015. On the 1st of February 2015, so that's 1 month later, he deposited €105 in the account. So he increased it by a fiver from the previous month. He plans to make deposits on the 1st of every month, increasing the amount that he deposits by a fiver. How much will he deposit on the 1st of December? So you need to figure out which term would the 1st of December be. So every month is a term. So on the 1st of January, it's 100. 1st of February, it's 105. 1st of March will be 110. 1st of April will be 115, and so on. Okay. So if I count the months from the 1st of January 2015 up to the 1st of December 2019, okay, when he's making his deposits. So remember, there's 12 months in a year. So you'd be counting all of 2015, all of 2016, all of 2017, all of 2018, and all of 2019, because he makes the deposits on the 1st of each month. Okay? There are 12 months in a year. So that's 5 times 12 months, which is 60 months. So by the time he gets to the 60th month, I want to know how much would he be depositing in the account. So I'm basically looking for term 60. So it's an arithmetic sequence. Those were the first couple of terms each month, what he was depositing. So A is 100, D is 5. Put down your T of n formula and you're looking for term 60. So term 60 should equal A, which is 100, plus n minus 1, so 60 minus 1 times D, or common difference, and that works out to be €395. So on the 1st of December 2019, he will deposit €395 into the account. In total, how much will John have deposited by the end of December 2019? Now remember, he's still only putting the deposits in on the 1st of the month. So it doesn't matter that we're now at the end of the month. Okay, he put a deposit in on the 1st of that month. They said in total. When you say in total, that means find the sum of. So I want to find the sum of all of those deposits. So his very first one, his second, his third, all the way down as far as his 60th deposit. Okay, so it's the sum of that series. So you put down your S of n formula, and I'm looking for the sum of those 60 terms. So 60 divided by 2 times A, which is 100, plus n minus 1, so 60 minus 1 times 5. And you get out €14,850. So that is the total that John will have deposited in his bank account from the 1st of January 2015 until the end of December 2019. That's how much he will have deposited. Okay, there's no mention of any interest being earned or anything like that.